In this first video on matrix transformations, we'll be looking at rotations. So the general principles when constructing our transformation matrices is that we develop the first column of our 2 by 2 matrix by considering what happens to the point 1, 0 under the transformation. Now some of you might think of that in terms of the I vector. So that will give us the first column of our transformation matrix, and then we develop the second column by considering what happens to the point 0, 1 or the J vector under the transformation, and that will give us the second column of our transformation matrix, and we'll end up with a matrix ABCD. So rotations, we want to create the matrix which defines a rotation of theta, radians or degrees, anti-clockwise about the origin. So first let's have a look at the situation here. We consider the point 1, 0, which is going to, under the rotation, map onto the point A dash, which is at coordinates x, y. And firstly, we're going to look at the x coordinate represented by the green line there. So in that triangle that's formed, cos theta is adjacent over hypotenuse. The adjacent side is x, the x coordinate of A dash, and the hypotenuse is 1. And so x equals cos theta. Looking at the y coordinate, which is the red line in that triangle, sine theta in that triangle is y over 1, so opposite over hypotenuse, which means that y equals sine theta. And so the point A1, 0, maps onto the point A dash, cos theta, sine theta, and hence we have the first column of our rotation matrix. So to get the second column of our matrix, let's consider the point 0, 1, which maps on to the point from point B, 0, 1 to B dash, x, y. And firstly, we're going to look at the x coordinate of B dash. So sine theta equals negative x over 1. We're going to get a negative value for x. And so x equals negative sine theta. Then we'll look at the y coordinate. Cos theta adjacent over hypotenuse, which is y over 1. So y equals cos theta. And that implies that B, 0, 1 maps onto point B dash, negative sine theta, cos theta. And so we have the second column of our rotation matrix, negative sine theta, cos theta. So for general rotation theta in an anti-clockwise direction about the origin, our rotation matrix is defined as cos theta, negative sine theta, cos theta.